Welcome, dear guests. Today we have a webinar called Innovation in Mapping and Architectural Documentation in Archaeology. We organized first of the same webinar in Turkish version 2 weeks ago. There were more than 100 participants from various disciplines, such as archaeology, architecture, geomatics, and informatics. This time we organized this webinar for a smaller international archaeologist and architect group, mostly work in archaeological survey or excavation projects in Anatolia. As you know, fieldwork is mandatory for some professions. Surveyors, mining engineers, civil and structural engineers, and many more disciplines are working on field data. Projects are being planned in the office by processing the field data collected with field surveying equipments. Excavation, construction, restoration, and such implementations are carried out at field according to the projects generated with post-processed field data. Compared to the field sectors, in archaeology, there is mostly no planning process because there is excavating rather than building. However, data is collected at field, traditionally processed on graph papers, and digitized in the office. As FieldTech team, we are carrying out mapping and architectural documentation part of archaeological documentation process. Argofield real-time documentation platform helps having reliable outputs with 19% less time, 60% less workforce, 50% less operational costs compared to conventional methods. Our services at fields are infrastructure creation, architectural documentation, and site analysis. Mapping and architectural documentation process was conducted without digital tools until 80s. Mostly local coordinate systems were in use instead of universal coordinate systems. Lack of digital interfaces such as CAD platforms and advanced surveying devices such as global navigation satellite systems, robotic total stations, laser scanners, and unmanned vehicles causes unprecise outputs. The technology reached out today remarkably facilitated mapping and architectural field recording. However, the current situation in architectural field drawings is almost the same. Even in developed countries who has high-tech devices, archaeologists and architects use traditional tools for architectural field drawings. Here, an outline of buildings in Gültepe is shown. The drawing belongs to 2015, drawn by me facilitating graph paper and GNSS. This image, also from the same year, reflects 1:20 scale stone plan of an unearthed area generated by using graph paper, pencil, and folding ruler. In academic publishes, conferences, and during their preparation, you would need high-quality digital materials. Thus, hand-drawn materials needs to be digitized in CAD platforms. The digitization process is very sophisticated, time-consuming, and may cause failures if the necessary controls are not carried out in each steps. As you see in this image, there's digitation steps of hand-drawn materials. However, when hand-drawn materials from different times are overlapped, coordinate grids and buildings may not be coincided. Figuring out which drawing is in true position and which is not that easy, because most of the remains were carried out for excavating and reaching out new material. Argofield is a real-time surveying platform. It provides freedom for surveyors as a poetic design and a game-changer technology. The slogan of Argofield is "We bring the office to the field." Conventional project cycle is sophisticated, time-consuming, costly, and requires the data transfer among several equipment and software. Data is collected from surveying equipments via controllers, such as handheld units, tablets, and joysticks, and the data post-processed in the office. While conventional documentation process needs office for post-processing the data, real-time documentation solves whole process in a single mobile platform. Real-time data processing with Argofield helps to ease and accelerate the project cycle, reduce operational costs, prohibit data loss and errors. Argofield system gathers all devices and software needed during the project cycle. Additionally, it's a flexible system that user can customize it according to required tablet PC, surveying device, and software. Argofield's current development provides compatibility with GNSS, robotic total stations, and unmanned aerial vehicles. However, it is going to be integrated with laser scanning devices, which is almost only technology to document organic forms such as caves precisely. As FieldTech, we developed Argofield as a user-friendly platform. It has both a hardware and software solution. Hardware contains buttons for real-time processing and joysticks for scrolling the screen. Because it has an ergonomic design, you do not need to leave the device while processing the data. Whole buttons are placed in the hardware properly to mobile use. FieldTech Assistant is a software interface we developed to ease, facilitate, and organize the fieldwork. It has login tool, an observation panel, a toolbar, and settings interface. Connection of the surveying device, project's data entrance, and coordinate system selection should be done before using the CAD platform. FieldCAD is an AutoCAD Civil 3D plugin, has customized commands for field data processing. The commands are generated in order to ease field drawings. They are mostly combination of various CAD commands. User can define a coordinate grid, easily draw an architectural block, and so on with these commands. While FieldTech is in use, observation panel is open. Thus, user can control the data coming from surveying devices to be sure about the precision. Argofield is a value-added and innovative system. It is completely new in the sector. It is integrated with most common surveying devices and CAD platforms. It is a flexible platform which is compatible with different size tablet PC, so user can choose his own PC, like in 10-inch or 14-inch. We use 12-inch at the field, and in CAD software inside. Let's look at the user scenario. There are some differences from the conventional methods and some similarities. We always take our equipments with us to the site, but the process at the office is shorter here, like in photogrammetry, but we got all the data and process all the data for architectural drawings in the field. There is both aerial and terrestrial survey in the scenario. Why not only aerial survey? Because there are plantations and some objects in the field, like also unexpected things like buildings sometimes. So we have to survey them terrestrially by using GNSS, total station, and that kind of stuff. So yes, aerial photogrammetry and aerial documentation facilitates so much, but it's not enough. We have to do terrestrial survey as well. Our very first case we tested Argofield was in 2019, I'm sorry. There was 20-hectare big Amos archaeological site in Marmaris. We provided service to our customer, Muğla Sıtkı Koçman University. We both use aerial and terrestrial documentation techniques. We delivered the outputs within 2 months from the beginning of the fieldwork. While we compared the results with conventional documentation techniques, Argofield provided more than 70% productivity. The outputs are emerged in 90% less time, with 60% less workforce and 50% less operational cost. Additionally, all outputs were reliable with high precision. I am going to tell about what we do in fieldwork as service. Especially at the beginning of an archaeological survey or excavation, an infrastructure would be needed. What are the items of infrastructure? Design and installation of ground control points, high precision static survey and leveling of these ground control points, generating a base map, road and paved design accessibility is also important, and digital inventory systems. These designing, production and implementation of durable ground control points to the strategic points, having their high precision measurements would help conducting safe and sustainable excavation process for a long time. As you see, we implement them on the ground, and we have a painting on them to mark their numbers and keep them safe. Afterwards, we have high precision static survey and leveling for getting high precision coordinate data, both X, Y, and Z axis. What is high precision static survey? We put simultaneously many GNSS on the ground control points. They are simultaneously get the data from satellites and also they send the data to each other. There are also some stations from Topkadastro. We get their coordinate data and have their calculations. In that way, we get very high precisions, like under centimeter, 7 millimeters we got this year, coordinates. Leveling is also important to get their height data in Z axis. High precision static survey is not enough to get this, because they should be accordingly in good position, and so we use leveling in this method. To generate a base map, we both use aerial and terrestrial surveying methods. We implement temporary control points to the field by using Argofield real-time documentation system attached to GNSS. We get their coordinate data. We plan a flight route and get aerial images, post-process images with the coordinate data. Thus, we get 3D point cloud, generate 3D surface model of the site and base map with 1 meter contour lines. There's one example of a base map, 1 to 1000 scale. Accessibility of the archaeological site is as important as other infrastructural applications. Both geographical condition, site analysis, and archaeological remains are crucial to design best route. Incline, width, material, and such decisions must meet the requirements of the site. Another thing is maybe one of the most important ones for you, digital inventory system. we integrated an interface with Argofield, FieldTech assistant interface. It's digital inventory. You can customize it. You can open how much column you want. You can get report in Excel format. You can upload photo or drawing in the system. The best thing here is the tablet PC is with you at the field, so you can digitally put the data inside the system, and you can get the coordinates with GNSS, so you don't need to write all the coordinates manually. We also have architectural drawings of the sites. It includes, it starts with obtaining drawing standards. As you know, all archaeological sites has their own characteristics. They are different from each other. So we have to obtain a standard for each archaeological site. We draw stone plans, schematic plans, elevations, sections. We also do structural analysis and 3D modelings of the buildings. What do I mean with drawing standards? In CAD platform, there are layers and their properties. As architects, we need to show the buildings to observer in technical characteristics. So we need to use layer properties, their colors in a good way and true way. So we categorize sometimes buildings, sometimes the time that buildings constructed or time period people lived in. So this is a drawing standard. Stone plans is divided into two. There are in situ stones and debris. We use different layer systems for these two. So you can close, hide debris and see only in situ blocks, or you can open both and can see how much stone remains in the area. There's an example of stone plan. There's a church in Mokisos. As you can see, debris is light gray, so we can easily see the contour lines of the church. Schematic plans are also important. It gives observer an idea what the building was, how it was look like in plan, and to compare them each other. It's good to have their schematic plans besides stone plans. Elevations are important. We mostly see difference from time in elevations, like some stone blocks may be added in different time period. Elevations gives us a lot of information about it. We utilize from orthophotogrammetric photos while drawing this. So photogrammetry is not in use only aerial photo imaging, but also we can use it for vertical imaging. We also analyze structure of the building, how building blocks were in use, how was building system, why these buildings stand so many years, from their sections, elevations, and building system. We get a lot of data. 3D modeling is the last one of the architectural drawings. This actually gives us option to see the site and buildings without going there in 3D. Another service is site analysis. It contains 3D surface modeling. These are textured models, digital elevation model, land sections, orthophoto, and urban analysis. It doesn't matter how big the area is, we can generate a 3D model of the site. These images from Mokisos, it was 200 hectare big area. These are not photos, these are models. Digital elevation models also important to figure out their topographical situation. And land sections are important to see the relation between buildings and the land. Here in the upper picture, you can see that theater building was located in a natural hill. This is a coordinated orthophoto. And also, this is important. The first time this year we tried to do it. We analyzed all geographical elements with architectural elements. The settlement characteristics are understood very well with these analyses. So we can see that the scale is very important. We should analyze the settlement both in bigger scale and smaller scales. Here we saw the relationship between terraces and buildings, the valley and buildings, and so on. I am closing to the finish to the presentation. I will tell you about the pricing system of our service. Ground control points are priced per piece. Area and land character is affected on pricing base map. Length, width, character of the road, and land characteristics are parameters for pricing road design. For architectural drawings, we are looking at the site and see the density and area, how much they exploded. It's also calculated in a rational table that we calculated. Schematic plans are the same. And also we have VR applications, not only technical drawings. For VR applications, the scenes, 3D model, quality of the view, UI and UX design is affected on pricing. Our business model is not only providing service, you can also buy or rent Argofield with whole system. We also provide education in this business model. Why FieldTech? Because we have an expert team consisted of surveyors, architects, urban planners, art historians, and developers. We are capable operationally because we have the technology, equipment, and software. We try to be as professional as we have contracts with our customers. In these contracts, business plan, cost analysis, and payment schedule are defined very well. And we also report all the things we did and deliver our customer, like surveying and mapping report and architectural report. Finally, I would like to introduce you FieldTech team behind all process I mentioned to you during my presentation. Our team is consisted of architects, urban planners, surveyors, historians, designers, and developers. Please follow us from our social media accounts and visit our website to get more information. Do not mind asking any question anytime by contacting us via email or phone. Thanks for joining us. Hope you enjoyed the meeting. I would like to invite you to a Q&A session. You are welcome to ask any question in this session. Yeah, I'm waiting for the questions if you have.
I have one, a very brief, because I'm curious for my own research. You talked about digital inventory system.
Yeah.
And I was wondering if this is a system to be used just on the site because you're in a hurry and you need to register things, let's say objects that you found, or is it can it be used in your depot when you're finished with your excavation, when you want to make a catalog of the objects?
Yeah, of course. Actually, there is a database behind this system. It's both online and offline system, and you can have any changing anytime on this system. After you changed any data, you can get a new report. So I hope this replies your question.
Yes. Thank you. Thank
you. And also the tablet PC we use at the field is an attachable device. What does it mean? You can use the same tablet PC as a computer laptop in the office. So you don't need to transfer the data into any computer. You can bring it to the office, attach the keyboard, and use the same device to manage all the data.
Oh, that's helpful.
Thank you. Any other question? Hi all. Anything else that you want?
Thank you for the presentation.
Thank you very much. I'm happy to have you all here. Actually, it was to a smaller group. This time we didn't invite all people to this webinar. We just wanted to have international guests, especially. But you are all welcome because we had our last webinar 2 weeks ago. Some people missed them, so it's nice to see Turkish guests here as well.
Teşekkürler.
Teşekkür ederim ben de. Alexandra.
Yes.
Hey. Could you watch all presentation?
No, I missed the beginning of your presentation, so I think I missed the important part. However, you provide the site or something so I can do some research. What you're doing, right?
Okay, actually, we have recorded the meeting.
Yes, that's true.
I will put it into our YouTube channel, and I can share the link with you via email if you like.
Yes, thank you so much. But if there's no problem with that?
Will you ask a question?
No. Okay. It would be better if I could watch the beginning of your presentation, otherwise it doesn't make sense.
Okay. Thank you very much.
Thank you so much.
I think I would finish the meeting here if there is no more question. We actually have one more participant. I would like to apologize. Yeah. Helena or Yelena? Yeah. We are going to finish here. I recorded the meeting. I will upload it to our YouTube channel. If you missed any part of it, you can rewatch it and share it if you think anyone will provide from it. Thank you very much.
Teşekkürler.
Bye bye. Thank you.
Thank you. Looking forward to see you later.